So in this section, we're going to go through the basic configuration of PEMPro for your Lost Mandy mount and your Gemini computer. We're going to be using Gemini 2, but a lot of this is also relevant for Gemini 1. I'm not going to go through any particular differences right now, but for Gemini 1 folks, you should basically be able to follow along and have your functions and your results be pretty much the same. So I have here, this is a shared screen from my computer on the top of my telescope. You can see that. It's a remote desktop. And I have PEMPro up and running. This is not the absolute latest version, but I'm going to put a link in the description below here that's going to show you where to download the latest version, 3 version, kind of whatever it is. So just take a look for that. And the first thing we are going to do is we are going to create our mount using the mount wizard. So I'm going to go ahead and name this the Lost Mandy G11. This is my G11 mount. And for the mount type, this is the first important thing. We're going to choose not G11 or G11 Gemini or Skywalker or any of those things. We're going to choose Gemini level 4.5, and that's important because it gives us some added capabilities in the software that you'll see later on that allow us to actually, kind of do Gemini-specific things, uploading curves and downloading curves and so forth. So I'm going to click Next. Now here is the ASCOM driver. I'm actually going to use the ASCOM driver for connecting. So I don't, since I've done this before, since I've already set this up, I don't need to do it again, but I'm going to show you just in case. This is a kind of a standard telescope chooser. Here's my Gemini telescope.net. Here's the properties. This is all the things that are the things that I've set up previously. And then I'm going to click Finish. And I'm going to go back into Configure Scopes and Mounts because there's 2 additional settings I need to put in here. One is the guide rate, which is 0.5. That's the default. And you want to keep that. You don't want to change it, and you don't want to, you don't want to change it. You just want to keep it at the default. There's just a lot of reasons why that's the case, but that's the default out of the box. So just type in 0.5 and you'll be in good shape there. And then later on, I'm gonna specify my image scale, but I'm gonna go ahead and type it in here. It's 1.06. You may recall this is what we did for, in step 1 or part 1 of the practical periodic error tutorial here, is to actually determine your image scale. So this is actually where you would type that in. And I'm gonna go ahead and save that and close this. And I'm going to go ahead and connect to the scope. So it is unparked now. It was actually in the park position at the counterweight down, but now it's obviously tracking. And now we're going to go to camera. So for camera choices, I usually choose either ASCOM or my imaging camera, my imaging program. So that's Maxim, Sequence Generator Pro. I don't think a lot of folks are using CCD Soft, but that's another one. And the reason, let me just tell you, the reason why I use the imaging program and not the built-in ASCOM is because in the imaging program, I need to do things like change my filter wheel here. So I got to make sure it's on the luminance and not some other color, like hydrogen alpha, which will of course block all the starlight out. I may need to run my focuser, which is important. And also you can see here I have a flat box that I need to open. It's a flip flat, so it automatically opens and closes. So I'm actually going to use Sequence Generator Pro as my connection thing. Now I've connected everything. I've got to pre-connect my camera, my filter wheel, and so forth. So this is up and running. I've already focused my camera. I've already set the filter position. So these are all the things that you would do that you would normally do at the start of any imaging night. We just happen to do them in preparation for some data collection for periodic error correction. But this is going to run in the background. I'm not going to worry about that. And when I click Connect Camera, it gives me some options. I never change these at all. I just click OK. And we are connected. Now, one of the things I do right away is I'll bring up my Gemini tracker here, or my Gemini little sort of soft hand controller. And if you recall in part 2, we talked about setting a home position that's near the celestial equator and the meridian, the intersection of those 2 things. So what I'm going to do here is choose now Park at home position, and I'm going to say yes, and it's hopefully going to slew there. There we go. And what's great about this is this allows me to instantly go to the right place to start my data collection, and then later on at night when we have to return to that position and to run a verification run for PEMPro, it's just a matter of kind of clicking a couple buttons and going right back to where we need it to be. So that's a really handy way to go about this. So it's going to slew a little bit. It takes a while to get from counterweight down to the home position. Hopefully it shouldn't be too much longer. There we go. And you can see the tracking is turned off. Now, what's important here is I want to verify using one of the built-in tools how to go about making sure that this is actually kind of in a place that PEMPro thinks is a good starting point. So what I do here is I'm going to use the calibration wizard. And you can see the declination, the right ascension, hour angle are all green. This little dot here actually shows me where the mount is pointed, which is all great. So I'm actually totally fine with this. And in fact, I'm just going to kind of go ahead and go through the rest of the steps here on this wizard just to make sure that the calibration of this is correct. Now, step 2 is really about determining the image scale, which, as you remember, on our part 2 of this thing, we've already figured out. So I'm not too focused on the image scale, but I am concerned about the image angle. It already knows the declination that it's picked up from the mount. So these are kind of these 3 settings right here. So what I'm going to do is I'm going to go ahead and let it take an image for 20 seconds. I think it, if I'm not mistaken, I think it stops the tracking. Well, the tracking's already stopped, so presumably it's going to continue stopping of the tracking. And then it's going to open the star trail. Now you'll notice down here in the bottom, whoops, that actually Sequence Generator Pro is exposing that, so it's going through the API. And I hope it's going to bring up, here we go, there's the star trail. Now, and again, I apologize, this particular cursor does not work well when it comes to kind of remote screen, but I'm gonna do my best. And what I'm really interested in is the angle. So I'm gonna kind of line this up here. What you do is you click on one end and then click on the other. And I'm going to kind of scroll around a little bit. It's pretty light out, but you can find a few of these. And I'm not so much concerned about the image scale because I've already typed that in. I've already determined that from part 2. But I'm going to look around for maybe one more. Oh, here we go. Here's a couple of good ones. Now, if the cursor was working correctly, you would use this target, and you would actually put it, right at the end of that, or sort of right in the middle of that. But unfortunately, for whatever reason, it gives me a big black square. So I'm doing it a little bit differently. I'm going to click here. I'm going to click here. And one more. Why not? And we're going to do that. That looks pretty good. So the image angle, so my arc seconds per pixel is a little bit off. And again, you're talking about a couple hundredths of a difference here. So I'm going to say this looks good. I'm going to save and exit. And my image scale has changed a little bit. Now, again, I can go back and sort of put in my original values, but it's got my image angle, which is important, and of course it's got my declination. So I'm going to go ahead and click next. I can skip this step, so this is step 3 to determine the auto guider axis and guide rate. I can skip the step if PEMPro can write the PE serve directly to the mount. And in fact, here it is, Gemini level 4 and Gemini level 5. So in fact, for the 3rd step here in the calibration wizard, I can skip it. Yay for Gemini. So I'm going to skip this. And then we're going to determine the movement direction here. So what I do, I actually find for my mount, I need to do the image duration in 30 seconds. It goes up to 30 seconds. I think the default is 20 seconds, but I'm going to go ahead and do 30 seconds. Just click the start button. And I believe the way this works is it kind of stops the mount or moves the mount and then sort of stops it and moves it some other direction. But essentially, it takes a picture and we try to figure out which of these other pictures actually line up with it. But this whole calibration wizard part of things is very important to do because you want to make sure that PEMPro is configured properly and we're gathering data correctly for my mount. Exposing, when star trail's done, it's going to be 30 seconds. Okay, so that looks pretty obvious as to what this is. So it's going to go, let's see, it's going to go this way and then down. So I hope I'm not going to screw this up. Exit. So I think, yeah, that's the one I want. Okay, and then we are going to finish. All right, so we've managed to get through the calibration wizard. At this point, we're just ready to collect data. And I want to show you something here. Actually, my mount has the periodic error correction. It's already defined, and it's defaulted to be on at startup. So I'm going to go ahead and turn this off because I want some raw data collection here. So now that we've got this all kind of working, we're going to go to Acquire Data tab. And here's what I like to do. I like to run this for an hour. So this is actually the stop time and the number of hours. We're going to click Enable Automatic Stop after 1 hour. And what this means is it's going to collect data for an hour and then just stop tracking. And what I'll do later on is I will return and repark it at the home position and start tracking again. So when I do my verification, we're starting at exactly the same point. I tend to like my exposures probably about maybe 2-3 seconds. So I'm going to do 3. I put 0 delay between them. I don't think that's important. And again, where you have the correct image scale, just kind of repeated here. So I'm going to click Start. And it says, of course, it wants to make sure that I know that my mount's PEC is off. Well, turn it on or off, whichever one I want. So here, I've obviously turned it off already. We're going to go ahead and start up our data collection process. So I'm going to say OK. So what it will do is, and you can see Sequence Generator working down here. It's doing these exposures. It does a full frame exposure, and then it does a star selection, and it will start just kind of plunking away these points. So now I'm in the data collection process. And if I actually switch to Sequence Generator here, well, let me get rid of some of this, you can see it's actually just taking picture after picture after picture of this star, and it's recording the data. So it works really nice. Now, if you are, let me go back to this. If you are using the ASCOM Direct Connect, you might see a little window pop up, and it will show a star or something like this. And it will actually, I think it pops up and it ends up being really quite large. Don't dismiss that because that's the star data that it's using. So I just kind of make it a lot small as I can, make it a lot smaller, and just put it off to the side and watch this. Now, I'll just also mention here, this is starting out, and you can see there's a bit of a drift here, but the actual points between themselves are relatively smooth, right? I don't see a lot of jumps here. So what this is telling me is that this is actually a bit of polar alignment error, which is possible. I haven't gone out and fiddled with this scope much yet, but that the mount itself probably has not a lot of errors in terms of RMS, so it's a nice clear night, not a lot of jumping around, and I haven't seen any big jumps here in terms of the periodic error. So we are going to let this run. I'm going to let it run the entire hour, and we're going to come back later and we're going to take a look at the data and analyze it and see what we can do about putting together a curve.